Hello, my name is Rita Davda, and today I'm going to be giving a chemistry lecture on the states of matter, specifically solids, liquids, and gases. Let's start off. States of matter. In chemistry, there are three main states of matter that we look at: solids, liquids, and gases. Each of these states have different and unique properties that affect pretty much everything around you, from the reason why your water boils so slow to the reason why your honey flows so smoothly. Keep in mind that all matter is made up of atoms, and multiple atoms joined together is called a molecule. When atoms in a molecule stick together to form different substances, they are joined by what we call intermolecular forces. These forces are basically the glue that holds together enough water molecules to form a glass of H2O or really any other substance. Intermolecular forces are of varying strengths and stand to further explain and clarify some of the properties of states of matter. These forces are a bit complex, but they're very relevant to what we're talking about today, although it is not our focus. The picture here shows three glasses filled with gas, liquid, and solid in the atomic representations. You can notice how in the gaseous form they are spread out and almost seem to be floating. In the liquid form, they're flowing smoothly, but they cannot float. And in the solid form, they are rigidly packed and tight. Our lesson guideline. A large part of conceptual chemistry revolves around the existence of three main states of matter: solids, liquids, and gases. It's important to learn about how atoms exist in these states and how they go through changes to reach different states, like how solid ice melts to form liquid water. The topics we're going to cover today are the introduction to phase changes and heat transfer, which will set us up to learn about solids and their properties, liquids and their properties, gases and their properties, and then there'll be a short summary and some practice problems at the end. Phase changes and heat transfer. Substances can change their state of matter from any one state to another, even something you may not think about, like from a solid to a gas, by skipping the liquid phase. That's referred to as sublimation. The reverse is also possible, going from a gas to a solid, again skipping that liquid phase, and it's referred to as deposition. The process of changing states can either absorb energy, often in the form of heat, or release energy. A chemical process that absorbs energy is referred to as endothermic, as it takes in heat and makes the surroundings colder. Another way to think about this is by thinking about movement. Moving takes more energy than resting, so changing to a state with more particle movement, like from a liquid to a gas, means you have to input energy. On the other hand, a chemical process that releases energy is referred to as exothermic, because it gives off heat energy during the process. You can think about this as how during an exothermic process, energy is lost in the form of heat. So for example, changing from a gas to a liquid means that the particles of the substance have to slow down, so energy is removed. Here, this is called a phase change diagram, and you see on the vertical axis is temperature and the horizontal is heat. You can see how it goes from solid to liquid to gas, and it's labeled with what the phase changes are. So solid to a liquid is melting, and liquid to a solid is freezing. It's a good visual explanation of how some of these phase changes work and the tiers of how solids, liquids, and gases can change between each other. Solids and their properties. When atoms are in a solid state, they are held in place in a rigid formation, unable to move. However, atoms in the state can vibrate, which is where the heat energy comes from. An example of a solid would be gold or ice. Their shapes are unchanged and they do not move or flow to fill the space of their container. Solids have a definite shape and a definite volume, and they usually have a higher density, since the atoms are packed so tightly. Solids generally have a high melting point because it takes a large amount of heat energy to overcome those intermolecular forces, which are what we talked about earlier, the attractive forces between atoms in a molecule. And that's what will melt it and change it into a liquid. There are multiple types of solids that we won't really get into, but it's good for you to know, such as ionic solids, metallic solids, network covalent solids, and molecular solids. All of these solids have different properties, but they share common ones as well. And just for clarity, solids are denoted by S in a reaction. The visual here is a solid cube. See how they're rigidly packed, they're not able to fill the walls of their container or move, and the atoms are fixed in place. Liquids and their properties. When atoms are in the liquid state, they can flow more freely than those in the solid state, and thus have completely different properties and characteristics. These atoms don't vibrate because they're not held in a rigid formation and they can move more independently. An example of a liquid would be liquid water. They have a fixed volume and not a fixed shape, so they fill the walls of their container as far as this fixed volume permits. When enough heat energy is added to a liquid, it will reach its boiling point, meaning that the intermolecular forces within the liquid have been overcome, and the liquid can become a gas, like when you boil water and the steam comes off of it. Fun fact, water has a very high specific heat capacity, which is the amount of energy required to raise the temperature of a substance by a single degree Celsius. This is why it takes a long time for water on a stove to boil, as opposed to other substances. Another interesting property of liquids is capillary action, which is the spontaneous rising of a fluid without the help of or against gravity. Think of putting a towel in a puddle and watching the water rise up it. There's two types of capillary action, cohesive and adhesive. Cohesive forces occur when the forces between the molecule of a liquid are stronger than the forces between the liquid and the container that it's rising up. On the other hand, adhesive forces occur when the forces between the liquid and the container are stronger than the forces between the molecules in a liquid. And again, liquids are denoted by an L in a reaction. Now this right here is a diagram for water, and it shows the specific temperature and the pressure that it has to be in the solid state, the liquid state, or in the vapor state. It's interesting to see how you can change your temperature and watch how it turns to water vapor, but if you increase the pressure, it becomes a liquid. Another way to think about how different aspects of chemistry are interacting, like pressure and temperature, affecting the states of matter. Finally, we have gases and their properties. When atoms are in the gaseous state, they are able to flow freely because the molecules have enough energy to overcome any intermolecular forces that would otherwise prevent them from moving freely. Gases have no definite shape or volume, and they expand to fill their container. They're also compressible, unlike solids or liquids. An example of a gas would be air or water vapor. Gases can be condensed to form a liquid, which is an exothermic process. Gases are an incredibly important part of chemistry, and they're a lot more nuanced than solids or liquids. Thinking back to the diagram we saw in the liquids slide, things like temperature, pressure, and even volume can all interact and affect gases in different ways, which we can get into later. Gases also have a low density, and unlike solids, have high diffusibility, which is their ability to fill that container that they're in. Gases are also denoted by G in a reaction. This picture here shows a gas, and notice how all the atoms have these arrows showing the direction they're going in. Gases don't all flow in one direction or stay together. They're constantly moving around their surroundings and changing, which is very interesting. To summarize, there are three states of matter: solids, liquids, and gases. Solids are rigid, and the atoms have limited movement. Liquids are fluid, and the atoms have some movement. And substances can change between states of matter. These phase changes can either be endothermic or exothermic. So we're going to do a practice problem. I'll give a few seconds for you to think about it. What type of process is sublimation, going from a solid to a gas change? Think of how we're either adding or removing energy in the form of heat from the phase change. The answer would be C, endothermic. And we also have a challenge problem. So which process do you think is easier and faster? Melting or vaporizing substance, such as water? Now the answer here would be that melting water is easier than vaporizing it. When moving a substance from the solid to the liquid phase, the intermolecular forces within the substance don't need to be entirely overcome, since both solid and liquid have particles that cannot move completely freely. This is due to an idea that the intermolecular forces weaken as the distance between the molecules increases. Think about how in a solid and in a liquid, the particles are closer together, but in gases, the molecules are farther apart. When changing a substance from the liquid phase to the gaseous phase, these attractive forces between the atoms in a molecule need to be completely overcome so that the gas particles can move so freely. This means that it takes a lot more energy to convert something from a liquid to a gas than solid to a liquid. Think about how quick ice melts, but how long it takes for water to boil. And that's the end of our presentation. Thank you so much for listening, and I hope you learned something.